Section 6.2, it looks a lot like Section 6.1. Okay, the difference is, and this works for questions number 4 through 6 on the homework. Let's see, average number of magazines, average income, IQ. All of these are questions where you ask someone their number, okay? How much is your income, or how many magazines, or what's your IQ? They have to give you a number for an answer. So these are not yes or no questions. These are number questions. And then you think, well, what about number 7? Okay, the amount of time it takes to repair a car, that's a number. The difference between number 7 and 4 through 6 is how many people you asked. Okay, here in number 4, you asked 64 people, n equals 64. And number 5, it was 100 people. In number 6, it was 81 people. And number 7, it's only 12. When you don't ask very many people, then you're going to want to give yourself a lot of wiggle room. Okay, Z interval doesn't give you as much wiggle room as T interval does. So anytime n is greater than or equal to 30, n greater than or equal to 30, that's when we're going to go with Z interval. Okay, you've got you've got a lot of people you talk to, you're a little bit more sure. If you only talk to a tiny little handful of people, you just want your interval to be a little bit larger to cover yourself. So that's how you tell the difference on whether you're in section 6.2 or you're in section 6.3. Okay, now stat, test, Z interval. All right, so stat, test, Z interval is like choice number 7. Don't accidentally go into Z test. Z interval. Input, data or stats. Well, I'm not going to input the data. Input the data would be to write down all the numbers of all these 64 people, and it's not like the problem gave me that anyway. You're mostly going to use stats. Okay, if it's not on stats now, arrow on over there and hit enter to make it stick. Underneath that, it says sigma. Okay, sigma is the other standard deviation besides S. We keep using S, and this problem even comes right out and tells you if I used my standard deviation, if I had done a one variable stats, my standard deviation is a 1.1. Okay, and that's great. There's always this theoretical idea that somewhere or other someone else has done this study before, and so from past studies, the sigma for the entire population, that's what this one is if someone did the entire population, like it was the U.S. Census that did it or something, then the entire population, that would be their standard deviation. Well, we almost never use it because when is that going to come up? I'm going to ask the entire population. So we just keep going with SX. And it's really contrived in these problems that someone comes along and just happens to give you the standard deviation from past studies. So it's always going to be written into the problem, and that's the one that I should use because it does say sigma on there. Okay, so I'm not going to use this S, but it's really contrived. In real life, nobody ever gives you sigma, and if you were going to do this, you'd have to go with using S. Anyway, so sigma 1.2, X bar 3.2, N is 64, sea level, okay, what did it tell me? I didn't write it down. Number 4, sea level says 95% confidence, so sea level 0.95. And calculate. Okay. 2.906, comma 3.494. All right, great. I've answered the question. Now on here, it says construct a confidence interval. Okay, I've done it. There it is. There's my confidence interval. Now the other two say, and compute the margin of error. This one didn't ask that, but I'll just go ahead and do it anyway. Big minus little. Okay, so 3.494 minus 2.906 divided by 2 divided by 2 is 0.294. Okay, so this would have said, oh, well, the average number of magazines is 3.2 plus or minus 2.94.